Good afternoon. Our project name is COVID-19 detection through cough sounds by using CNN. My name is Sheikh Naveed Attaf. I am team leader of this team, and our team consists of 4 members. The co-leader is Satish and Lohit Ishwar, and remaining members are Madhuri. Now, project introduction is will be told by Madhuri.
Good afternoon. Now I'm going to explain about abstract. COVID-19 is a disease that has been declared by the World Health Organization in March 2020. The world faced coronavirus in 2019 and detecting COVID-19 in earlier stage for better treatment plan is necessary, and existing method are not so fast. In this work, we are proposing a method that can be detected COVID-19 with a short span by using machine language model called CNN. CNN means convolution neural network. To overcome our problem, analyze the convolution neural network has taken the samples of cup sounds. The main objective of our project to build a machine language algorithm that can be informed the diagnosis of COVID-19 based on people cup sounds to reduce the dialysis time.
Introduction. The existing techniques currently being used are X-rays, ultrasound scanning, and CT scans and RT-PCR. They demand in person contact and more time consuming. Our basic idea is to provide COVID-19 detection with cough sounds to extract its characteristics and compare with trained samples using COVID CNN and identify the COVID infected person. Literature survey. There are two existing methods we taken. First one is smart classifying of COVID-19 and pneumonia using X-ray and CT scan images with different CNN models like ResNet 50, Inspection V3, and VGG 16. The main drawback of this existing method is that it requires physical contact, and also X-rays and CT scans are very expensive. The second existing method is the presence of COVID-19 is detected from ultrasound images using different CNN models. They used 3,326 images to train the CNN model. The main drawback of this existing method is it predicts false prediction in case if the person affected by pneumonia.
Good afternoon. My name is Satish. In this project, we have a 5 segmentation. One is dataset, the second one is data propagation, and third one is train the model by using CNN model, and fourth one is prediction, and fifth one is real-time detection COVID-19. First step, data collection. In data collection, we take a data set from Crowdsource dataset. It is an open source dataset. It contains the COVID samples of positive and negative. In that dataset, converts the audio samples into ML images in default. In that, ML images are classified into 2 types, testing and training, with the ratio of 2:8. That ML images are taken and load into the program by linking that Google Drive with Google Colab. Firstly, import the train dataset from the drive, and next that images are perform a augmentation, image scaling, image resizing, and that images are taken into a batch size. Each batch contains 32 images, and total batches are contained 41 images, 41 batches. When taking by data samples, there are few samples are taken and few samples are rejected due to unwanted images, unpresence of data in that images. In here, we are taking a total 128 images in two classes, both positive and negative. 120 images for training and 79 images for testing. In here, graphically representing the taking data set. One is training data set and second is testing data set. In training data set, we're taking 100% data samples. Now, validation set, we're taking 100% data set. After that, we're taking first. After that, first you take a training images, training ML images. Training ML images are augmented. That augmented images are loaded into a MobileNet V2. In CNN model, there are different models present in like VGC16, VGC16, TensorFlow. Different models are present. Here we are using a mobile V2Net. Here mobile V2Net is a predefined mobile model. The predefined model are pre-trained, because using pre-trained model is to reduce the time to get accuracy and efficiency more. We take the training ML images and load into a model. After that, train model set in mobile V2Net contains different layers, convolution layer, max proving layer, and fully connected classifier layers and dense layers. After that, that images are classified and taken into trainable total parameters and considered only trainable parameters. After trainable parameters, model is developed. Next step is prediction.
Coming to the prediction phase, in our project we have divided the data set into two categories, and training and validation. Here we have divided into two categories, training and validation, and each category consists of divided into batches, where each batch consists of 32 images. Here we are using this valid generator images in the prediction phase. The prediction phase, we load the validating images into the model. After loading them, using model.predict function, we are predicting the images. The model.predict function returns a list of probabilities of the images. From the list of probabilities, we will select the maximum probability, which is called as predicted value. Now the predicted value will be compared with the trained model. Depending on the trained model comparison, the output is generated either positive or negative. Here are some predicted values and outputs. Here we have the validation. The validation part consists of only positive images. That's why we have get to all ones. Here one means COVID negative. COVID negative. 0 means COVID positive. We have represented 1 as COVID positive, 1 as COVID negative, 0 as COVID positive. And coming to the performance calculations of the model, we will find out some performance metrics like accuracy, precision, recall, and F1 score. The accuracy of the model is calculated by using confusion matrix, which is imported from the sklearn library. And from the same library, we also use classification report for finding out remaining metrics like precision, recall, and F1 score. Here, after getting the confusion matrix, we are displaying the confusion matrix using matplot library. Here we can see positive, truly positive observations and predicted positive observations. Here we have taken 79 positive samples. Out of 79, 78 positive samples are correctly predicted, and one sample is falsely predicted. And we can see in About training, we get accuracy of the model as 97%. After getting the confusion matrix, we will calculate the classification report of the model. In the classification report of the model, we will get the precision, recall, and F1 score. Precision, recall, and F1 score are the metrics which where we will calculate the prediction accuracy of the positive and negative samples. After the prediction, we will calculate the prediction values of positive and negative samples. This is done because we need to select a threshold value which is used to categorize between COVID and negative samples. For selecting that value, we have calculated positive predicted values of negative and positive samples. The predicted value of a negative sample is we get as 0.99, and for a positive samples we get in the range of 0.74 to 0.75. And coming to the real-time testing, in real-time test we have taken a cuff sample from a person in real time and converted it into Mel scale image. That Mel scale image is used to predict the model. From the Mel scale image, we extract the properties. We extract the properties and predict the model and generate a predicted value. The predicted value is here compared. The predicted value is compared to the threshold value. Depending upon predicted values of positive and negative samples, we have selected threshold value as 0.85. And in real-time testing, the predictions of the real-time sample is compared to 0.85. If the predicted value of the real-time sample is greater than 0.85, then output will be COVID negative. Otherwise, we will print output as COVID positive. Thus, we have find out we have categorized COVID infected and uninfected persons using CNN through cuff sounds. Thank you.